So today is just a continuation of yesterday. We're looking at sequences again, and as I said in yesterday's video, today's sequences are now dealing with multiplication or division. Excuse me. So a geometric sequence has a common ratio between successive terms, and remember that successive just means your terms that are all in a row. So here, our pattern, our sequences is 2, 6, 18, 54. So you may first be thinking to yourself, the pattern is that you multiply each one by 3. But sometimes if your number is bigger and not so obvious, you need ways to find it. So to find the common ratio, that is 3, the best way to think of it is term 2 divided by term 1, or term 3 divided by term 2. For example here, if you did 6 divided by 2, the term divided by the term in front of it, which is 3. Same thing if you did 18 divided by 6, it's 3. So what we call that now, yesterday was our common difference, today it's ratio. So our ratio in this sequence is 3. Now you can see here in this sequence it's decreasing. Still be sure you check the same way, that you do 20 divided by 40, the term divided by the term in front of it. So that way you can see that your ratio is 1/2. You're decreasing this time. 10 divided by 20 is 1/2. So here we say the common ratio is 1/2. Now what we're going to look to do here again in this proof is show a general formula that would help us. Because if we all of a sudden wanted term 100, we wouldn't want to have to write them all out. So here, if we look at, we're going to go through this sequence here. Term 1 is 2. So what we have is 2 times 3 to the power of 0. Let's just keep that in mind and see if we can figure out where these numbers are coming from as we continue on. So term 2 is equal to 6. So we have 2 times 3 to the power of 1. Term 3 is 18. We can get that number by going 2 times 3 to the power of 2. Remember, 3 to the power of 2 is 9, times 2 equals 18. So maybe because of yesterday it's becoming a little bit more obvious. Your exponent is 1 less than the term number. So if this is term 1, your exponent is 0. If this is term 2, your exponent is 1. The 3 came from our ratio when we divided it out, and 2 is the initial number in the sequence. So you're going to want this in your notes or on your study sheet as well. Our most important thing here in today's lesson, we were working at getting t at n is equal to a times r n to the power of 1. So Tn just means our general term that we can solve for any term number. A is our initial number, r is our common ratio, and n is the term number we are looking for. Move this out just for some space. So if we're writing a general formula here for this sequence, 5, 15, 45, we can see that r is 3, multiplying by 3 every time. So t at n is equal to 5 times 3 to the power of n minus 1. Now keep in mind, our general term we leave like that with the n's in it because it just gives us a formula where we can solve for any n value at all. For example, like t term 8. So we have 5 times 3 to the power of 8 minus 1. We have 5 times 3 to the power of 7, which is equal to 2,187. So just keep in mind what that means. This is saying that term 8, the 8th term in this sequence, if we kept writing these out here, the 8th term would be equal to 2,187. All right, let's look at our last example here for today. So if we're looking at t at n, our initial term of the sequence, the first term of the sequence is 6, and then we're looking for our r. So our r, I can first check by doing negative 3 divided by 6, which is negative 1/2. It's always good, though, to check that again. Be sure that you're correct. So 3 divided by 2, all over negative 3. Remember, that's sort of like negative 3 over 1. So when you're dividing a fraction by a fraction, you take the first one, change it to multiplication and the reciprocal. So I have 3 over negative 6, which is negative 1/2 as well. So I know my r is correct at negative 1/2, and then n minus 1. So if I'm looking for the 10th term, I have 6, negative 1/2 to the power of 9. 10 minus 1 is 9. I always do my exponent first. Don't work from left to right. 1 to the power of 9 stays as 1. Because 9 is an odd number, I know that my base is going to stay negative. 2 to the power of 9 is 512. And then I multiply my 6 in, so I have negative 6, 512, which gives me a final answer of the 10th term is negative 3 over 256. So the 10th term of that sequence will be negative 3 over 256. And just keep in mind, if you're going from here to here, it was just reducing fractions. 2 goes into both equally. We'll finish this tomorrow.